Section 9.1 is what I will be covering today, and in Section 9.1 we're going to be identifying possible identities using graphs, and we're also going to apply algebraic strategies to prove identities. So I'm going to start out with a couple of strategies when you're proving these. Here are 5 things that you can work with, and you'll see me use several of these in the video today. So first of all, one of the things you can do is try to get them to equal previously proven identities, so such as the Pythagorean identities or some of the identities like the fact that tangent is equal to sine x over cosine x. Another thing, so for the second one, write the entire equation in terms of one trigonometric function, and that's a strategy that will sometimes lead you to something like number 1. So maybe if you have sine, cosine, and tangent, maybe you want to transform that to just sine or cosine, or it depends on each one and what you are able to do. And then number 3, express everything in terms of sine and cosine. So numbers 2 and 3 are sort of the same there. Number 4 would be to deal with each side separately. So if you have sides A and B, change side A to equal C and side B to equal C, and then that's the same as proving that A and B are equal. And then the last would be to use cross products. So you know that if you have a fraction, then you know that the cross products are equal, so you can work with that. So if AD equals BC, then this must be true, and vice versa. So let's start out by thinking about how we could do this graphically. First of all, if I have this identity here, and I'm trying to show or trying to decide whether or not this is an identity, then what I can do is enter this as an equation, put that in as y1, and then enter this second one in y2, as you can see I've done over here. So I have my 2 equations, and when I graph those 2 equations, if they are equal, if it is an identity, then what I should see is exactly one graph. And as you can see here, I have a red graph, and that's this equation, and I have a green graph, which is this one, and so they are not the same. So this is not, these two, this equation does not represent an identity. They are not equal. So in this case, we want to say they are not equal. And another example on this one, again, we're going to put this in as y1, and we can put this in our calculator as y2. When you look at a graph, it turns out that all you can see here is the last graph that I put in, and that's because the blue graph is being covered up. And so in this case, yes, it is true, they are equal. It does look like we could prove that that we have an identity here. So now let's start looking at these algebraically, using some of our different strategies. So for this one, you've got a cosine, and so you're probably looking at this numerator here and thinking, you know, maybe I can factor it. But you're looking for things that multiply to be 1 and add up to 1, and that's not going to work out. So factoring's not an option for that numerator there. And so then we start thinking about how we can change things. So what I'm going to do is start on this right side, because I see the cotangent, and that cotangent makes me want to change it to cosine x over sine x. Okay? And when you look at the left side of the equation compared to the right side, you notice you have a fraction with a common denominator of sine x. And so it looks like we could have an opportunity there to come up with a single denominator of sine x. But if I'm going to do that, then this side here needs to be multiplied by sine x over sine x. Okay? And when I do, then I get that one sine x, which is this one, times this sine x, which is going to give me the sine squared x, and then bring down my cosine x. Nothing needs to happen here because it already has a denominator of sine x. And so now I'm looking at this and thinking, well, I still need to do a few things. And I notice if I look at the numerator on the left-hand side, that I'm dealing only with cosine x. So now that I have a sine squared x, I think it might be a good idea to recall that Pythagorean identity, sine squared x plus cosine squared x equals 1. We could say that sine squared x is equal to 1 minus cosine squared x. And I can put that in for, take that out and put in the 1 minus cosine squared x. And then add my cosine x over sine x. And here at this point you might realize that you do have the same thing you have on the left side of the equation. Just a little bit of rearranging, which we can do. 1 plus cosine x minus cosine squared x over sine x. And then we realize it checks out. We have exactly what we have. That is equal to that. So here we've chosen to just alter one side of the identity and set it equal to this side. Okay. Moving on. This time we are just trying to simplify this, put it into its simplest terms. So I see a secant, a tangent, and a sine, and that's a lot of different trigonometric functions. So what I'll do is maybe put those in terms of sine and cosine, which was one of our options. So I know that secant is 1 over cosine x plus tangent is sine x over cosine x times 1 minus sine x. And now it looks like I probably need to FOIL this, so I'm going to multiply here, and that's going to give me 1 over cosine x minus sine x over cosine x. Okay, and then let's do this part, which would give me plus sine x over cosine x, and then minus sine squared x over cosine x. And pretty quickly, hopefully you notice that these two would cancel. Okay, so we can get rid of that. And then in the next step, you notice that both have a denominator of cosine x. So we'll simplify that. 1 minus sine squared x. Okay, and then again using the Pythagorean identity, I know that 1 minus sine squared x can be replaced with cosine squared x over cosine x. And, from there I can just say that we have cosine x, and that is in its simplest form. Okay, moving on. This time we're trying to prove an identity, so we're trying to prove the two sides that are equal here. What I'm going to do in this time is use cross products here. Okay, and so if I use cross products, cosine x times cosine x is cosine squared x. So if I can prove that their cross products are equal, then I can say that the equation I have here is an identity. And then I have 1 minus sine x times 1 plus sine x. Okay, and at this point I realize I have a minus and a plus. Otherwise they're exactly the same, which means I have a difference of two squares. And when I multiply out a difference of two squares, I would end up with 1 minus sine squared x. Okay, and that's cosine squared x. And this, if I just alter it slightly, then I would have, by adding sine squared x to both sides, plus sine squared x equals 1. Then I realize I have the Pythagorean identity, which means that yes, this works out. Check. Okay. Again, we're going to prove another identity, and I think I have a wrong sign on this one. Yes, this should be a minus, otherwise it won't work out. Okay. So in this case, I notice again that I have a secant, a tangent, a cosine, a sine, a lot of things going on. So what I'm going to do is see if I can first of all take this left side and put it in terms of sine and cosine. So that's 1 over cosine x minus sine x over cosine x. Right, and I'm going to continue working with this side. I have a common denominator of cosine x, which gives me 1 minus sine x over cosine x. And then if I look at this other side, if I bring down this other side at this point, then you're going to realize let's change that. 1 minus sine x. Then I have those two are the same. Oh, and this sign should be a positive. That sign should be plus here. Okay. And at this point, now I'm going to go ahead and use cross products. And when I use cross products, I get 1 plus sine x times 1 minus sine x equals cosine squared x. Okay, here again on this left side, I have a difference of squares that's been factored, so I'll just change it back, which is 1 squared plus sine squared x equals cosine squared x. And then we realize once again this is, I must have a sign issue here again. 1 minus sine squared x. Okay, now we can realize that what we have is 1 is equal to sine squared x plus cosine squared x, which is an identity, so it works out. So we have now proven that the original is in fact a true statement, taking a couple of different routes. First of all, by changing to sine and cosine in this first step, then by applying some cross products and multiplying some things out, and then by changing it to a previously proven identity. So we have 3 different processes happening here. Okay, here we have 2. I'll start with A to begin with. On this cosecant, let's see, actually, okay, so here we go with A. Again, we're trying to prove an identity, and to me this left side, this right hand side seems pretty simple. Let's see if we can simplify the left hand side. So I'll do that by changing cosecant x to 1 over sine x, and then again the cosecant to 1 over sine x minus sine x. And we have that equal to cotangent x, and for right now I will just leave that. And then if we distribute this, then we will end up with 1 over sine squared x minus sine x over sine x, which is just 1. And what we're trying to do is prove that that's equal to cotangent. Is that equal to cotangent? So can we get it there? Well, I know 1 over sine squared x is cosecant squared x. And if you remember, cotangent and cosecant have a Pythagorean relationship. And I can quickly just change this to cotangent squared x plus 1 is equal to cosecant squared x. And so I've set it equal to a previously proven identity, which means that yes, this does work out. Okay, now let's try B. For B, we have cosecant, cotangent, and sine. So I think I will take this one and change the cosecant and the cotangent, change it so that it's in terms of sine and cosine. So first of all, by looking at cosecant, I know that's 1 over sine of x divided by cotangent, which is cosine x over sine x. and I want to know if that's equal to cotangent x on the other side. So let's go ahead and change that one as well. And then cosecant is 1 over minus. Okay, and so now we have it in terms of sine and cosine here. At this point, it still looks pretty complicated. You could simplify each side, would probably be a good next step. So if I take the left side, I can rewrite that as 1 over sine x times sine x over cosine x, and then you'll notice some things start to happen for you. These are going to cancel. And on the other side, if I'm going to rewrite that, then I first need to take this and do a little work to it. I need to get a common denominator, which in this case would be sine x. So I'm going to multiply by sine x over sine x. And when I do that, I'll have a common denominator of sine x. And then I would have 1 minus sine squared x in the numerator. Okay, so we have the division there, and so that would be the numerator, this numerator here, cosine x over sine x, times the reciprocal of this one, sine x over 1 minus sine squared x. Okay, and again you see some things that cancel out. And so from here, I'm left with 1 over cosine x is equal to cosine x over 1 minus sine squared x. Okay, and then we should know that we can take this and replace it with cosine squared x using the Pythagorean identity. And when I do, I have 1 over cosine x is equal to 1 cosine x over cosine squared x, which is equal to 1 over cosine x. And so at this point we've set the two sides equal to each other, and so it does check out. And one last problem here. So this one, I see that I have a fraction is equal to a fraction, which makes me want to use cross products. And if I use cross products, then I would end up with cosine x minus 1 times 1 plus secant x. You might also want to, at the same time, let's go ahead at the same time and put these in terms of sine and cosine. That could be helpful. So 1 plus secant would be 1 over cosine x is equal to, and now I'll work from the other direction, cosine x plus 1 times 1 minus secant x, which is 1 over cosine x. Okay, and let's see if we can have these, set these equal to each other. So I will FOIL, multiply these. That would give me cosine x plus cosine x times 1 over cosine x would give me 1. And then here would give me minus 1. And then here that would give me minus 1 over cosine x. Right? And then on the right side, cosine x times 1 and cosine x times 1 over cosine x would give me minus 1 plus 1 and minus 1 over cosine x. And here we see we have a couple of things that happen that are pretty nice that happens, which leaves me with cosine x minus 1 over cosine x is equal to cosine x minus 1 over cosine x, which are the same, which means we've proven that identity to be true. And that's all I have for section 9.1.